So you need to find those as well. And this will be your review for your test when we're done. You just need to upload this. There is a place for it. Make sure that you upload it to get credit for today. Okay. All right. So section 9.2 highlights. What are the tests to perform when you're given a proportion? When they say test, they're talking about conditions. And then make sure that you understand they're asking about a proportion or P. So what are the three things that we have to check?
Greater than 2% in large counts.
Mm-hmm. So remember, large counts is NP and N1 minus P. They all have to be greater than or equal to 10. So for proportions, how do you find the test statistic? Remember that the test statistic for proportion is the Z. So again, Z is for proportion. That is your statistic minus your parameter. Over the standard deviation of the statistic. So in terms of proportion, that is your P hat minus P sub O over the square root P sub O 1 minus P sub O over N. All right. So number 3 says calculate the test statistic. It says if the proportion of made shots is 80%, but we take an SRS of 60 free throws and the player makes 40, calculate the test statistic. So what do we know? What do we know from this line right here? Forget doing number 3 and number 4 for just a minute. What do we know from this?
That it's a proportion.
Okay, so we know it's P. What about it? What else?
The null hypothesis would be 0.8.
Good. So P sub O is going to be 0.80. And you can just put 0.8. That's fine. They don't care about that. What else do we need? Think about this formula right here to do the test statistic. What else do we need? We said N equals 60. And one more thing. How do I get P hat? Perfect. Which is, what is 40 over 60? If it's not, I think it's nasty, so we might just leave it as 40 over 60. Yeah, let's just leave it as 40 over 60. So ignore that I even put equals. It'll be fine. Your calculator will do it. If you want to put it as 0.67, that's fine. It's just going to make it a little bit off in your rounding. So I'm going to use the full proportion. So to calculate the test statistic, I have P hat, or 40 over 60, minus P sub O over the square root P sub O 1 minus P sub O over N. I suggest that you're writing all this down and you can use it over the next 2 days. I can't stop you from using it, so I'm not with you in your rooms. This will give you a Z of negative 2.58. Remember back, and I'm just going to tell you this really quick. Remember back, Rachel said it to begin with, that your null hypothesis was 80. And this free throw shooter that we talked about, we felt like he was lying and it was less than 80. So I'm going to go ahead and put that on there. Typically, you'll already have that, but I just wanted you to remember it when we get further down, okay? So find the p-value. Find the p-value. How do we find the p-value? Oh, what are we doing? It's z. So what do we do in our calculator?
Normal,
Yeah, normal. Remember, that's what we do for z's. We're trying to normalize. So normal CDF. The reason I gave you this is because you need to know where to put the 2.58 or the negative 2.58. So what is our lower? If we're doing less than? Negative 10,000. I swear, if you don't do good on this test, I'm gonna be so mad at you. You answer every question. All right, what's your upper gonna be? Come on, guys. What's your upper gonna be? Negative 2.58. Your mean, because we standardized and used z-scores, is gonna be 0, and your standard deviation is 1. That will give you a p-value of 0.0049. So again, remember why we did lower and upper like this was because we wanted the probability that z was less than negative 2.58. Okay, so that's why we put it in the order that we did. All right, so again, our p-value is 0.0049. Show this as a result, show this result as an area under the standard normal curve. If you get a question like this is super easy. You make your curve. We know that the middle is the mean at 0, +1, +2, +3, -1, -2, -3. We want less than negative 258. So this is how I show it so that they know I know what I'm talking about. And I want less than. And that just falls on the number line between -2 and 3. Try to put it where you think it is. Negative 2.58 is pretty much exactly between it. It's a little bit off, but you're not going to really show that. But the way that you show it is by putting your number up here. That's literally it. That's all you do. So there's your result under the curve. All right, tell what information should be in each step of the 4-step process. So in the state, what should we have in there? Hypotheses. So when you do your stuff tomorrow and the next day, preferably on Wednesday, that's when you're going to see it more. Make sure you have all of these things in there to get full credit on each one. Okay, so I'm telling you exactly what needs to be in there. What else?
your alpha level.
And one more thing. The parameter. You have to define that parameter. That's the one people typically miss. Okay, so make sure you have that. Now, realize anywhere that you put the alpha, so you guys know how when I get to the very bottom and I compare the p-value to the alpha, and I write p-value with p-value underneath it, alpha with alpha underneath it, that is the same thing. So as long as alpha is defined somewhere on the paper, you're going to get full credit for it. So I'd kind of make it redundant to make sure that you don't miss it in the top part. All right, so in your plan, what are you going to do in it? 2 things. And we know what our conditions are in the very top for proportions. And one more thing. Yeah, whatever your method is, if it's a t-test, a z-test, a z-interval, whatever it is, that's what you got to remember to do. What about in the do?
Okay, so I have a question.
Go ahead.
So do we use a 4-step process on all the questions, or is there like certain questions that we should use it on?
Anytime it gives you like the, okay, if you look at number 13 and number 14, see how it says, what conclusions can you draw?
Yeah.
That you're going to use the 4-step process. Now,
Okay, so
go ahead.
So when it says what conclusions you can draw,
Yeah.
use, okay.
Yeah, and you don't necessarily have to write the state plan do conclude, but you've got to do all that work. So all this does is help you remember like what goes where. So you don't even
Okay.
have to write this on your paper. You just got to make sure it contains all of this. So that's what I'm telling you about, like the alpha, as long as it's somewhere, as long as the parameter is somewhere, as long as all of this is somewhere on the paper, you're going to get the right credit. This just helps you organize it. That's all.
Okay, thank you.
You're welcome. What about in the do part? What are we doing?
You find your
Finding the test statistic.
What else?
and your p-value.
Good. I cannot write today. Test statistic and p-value. And of course, your p-value comes after your test statistic because you need that to find your p-value. And then conclude. You're going to decide what you pick. You're either going to fail to reject or reject H sub O. So you're going to decide which one you're going to choose, but make sure that you put it in context. I don't know what I'm writing today. And I think on 9.1, I don't have it right now. I have the outline here. I added the little outline behind your 9.2 and 9.3 if you've got the copies from me. So you have it. It's just not filled in. You can go back and check out where it was filled in the notes. Yeah, so it talks about what do you do if you have a p-value less than alpha, whether you reject or fail to reject. Okay, so 9.1 tells you about those. So just know that. All right, I'm gonna flip the page. Sketch the following on a normal curve if you have to do this. So the P is greater than P sub O. Here's your normal curve. If it's greater than, we want it to the right side of Z. So this is just the one-sided test, but it's on the right side. The next one is a one-sided test, but it's less than. So it goes on the left side. And then number 12 is a two-sided test. So it goes on both sides. And again, both sides should be equal. Mine are a little bit off, but it's okay. All right, so just in case they ask you to do that. All right, so 13 and 14 are what are important. This is kind of going to be on your free response. So when we look at this, according to the National Campaign to Prevent Teen Drug Use, 30% of teens aged 13 to 19, automatically right here, you see a percentage, that's going to tell you its proportions. They're not going to tell you on your free response what you have to choose, okay? So you have to know the difference between a proportion and means. So percent means proportion of teens aged 13 to 19 say that they have used drugs. The counselor at a large high school, we need that to make sure we can check those conditions, worries that the actual figure might be higher at her school. To find out, she administers an anonymous survey to a random sample of 400 of the school's 5,500 students. All 400 respond and 100 admit to doing drugs. Carry out a significance test at the alpha equals 0.05 significance level. What conclusion should the counselor draw? So what do we need in the state?
Our null and alternative hypothesis. Sorry.
No, you're good. What is our null?
P equals 0.30.
30%. What about our alternative? It's going to be greater than because she said she thinks it's higher. Very good. So this is a one-sided test. What else do we need in here? Which is? Good. And then the last thing we need is? And what does P stand for? On your test, I do want you to write it all out. Right now, you don't have to if you don't want to, okay? These are your notes. You choose to do whatever. I'm gonna write it all out so that you guys can see it. The true proportion of teams age 13 to 19 that say they have used drugs. Again, on your test, please write it all out. On your notes right now, if you don't want to, that's perfectly fine. These are your notes. So that's the state. We're going to plan. What are we doing? Not one-sided, but one. It's okay. You were close. One sample Z for proportions. You can do one sample Z test if you want to, that's fine. And that's if the conditions are met, you don't have to write that down. I don't suggest that you write that down. If you want to, it's fine. We need to check the random. 10% and large count. Is it random?
Yeah.
Why? SRS of 400. 10%, we do 10 times. Our sample size was 400. Do you think there are more than 4,000 in the population? Yes, it says right here, 5,500 students. So it's good. And then large counts. NP and N1 minus P. So 400 times 0.3 and 400 times 0.7. That gives you 120 and 280, which are greater than or equal to 10. So that works. So there's our 4 parts of that. Y'all, I'm telling you, this is what I'm looking for in your problems, okay? So make sure that you have all this information. I've listed it out for you. It can't get much clearer. So if you want to get all of your points, make sure that you do these things.
Do we need to write down the NP and N1 minus P?
I would, and the only reason that I would do that is because it defines what N is and it defines what P is. So if you don't write the formula down here, it's really redundant in the way that I do everything, but it's to make sure that you guys define everything the way that you're supposed to. Okay.
Okay.
So yes, I would go ahead and write it down. And then that way, if you forget to do it anywhere else, at least it's defined somewhere. All right. So what about the do part? What do we do? So like in this part, if you don't write this formula down, you've already defined it somewhere else. But I would suggest that you just keep writing it down. So I have P sub 0, but I don't have P hat. What is P hat? How do I get it? And again, that can come anywhere. It doesn't matter where you put that. They'll grade it wherever it's at on the paper. And then P sub O we said was 0.3. Again, you don't have to write it over here. As long as you put it in here, it's defined. So this is redundant, writing it both down here. I just wanted you to know where the 0.25 came from. So if you put it in this formula like this, that defines what P hat is, and you don't necessarily need this, okay? So just to let you know, P sub 0 is 0.3, square root 0.3, 0.7 over our N, which is 400, gives us a negative 2.18. Be careful of how you put that in. We're looking for the probability that Z is greater than negative 2.18. Where did I get greater than from? Our, our alternative hypothesis says greater than, so that's why we're doing it down here. So we're doing normal CDF because it's a Z. What is our lower gonna be? Negative 2.18. Our upper, ridiculously large number. Our mean, 0 because we standardized, and our standard deviation is gonna be 1. When you put that in, that gives you a p-value of 0.98. Sorry, that should be a 5. Got a little dyslexic there. 53. 0.9853. Then you're going to conclude. The way we conclude is we test our p-value against our alpha. Our p-value was 9853. Our alpha was 0.05. So again, that's where I was talking to you about, we defined alpha. So if you don't do it in the very beginning, it takes place of it. So don't freak out if you miss it somewhere. I'll make it so that you get it in there somehow. We know that our p-value is greater than alpha. So what does that mean? Fail to reject. H sub O. So we do not have convincing evidence that what? Of teens, age 13 to 19. Say they have used drugs. Yeah. If you look, the next question is pretty much the same as this one. There's just one little difference. There's one little difference. So it says, according to the National Campaign to Prevent Teen Drug Use, 30% of teens aged 13 to 19 say that they have used drugs. The counselor at a large high school wants to know if this national result holds true. To find out, she administers an anonymous survey to a random sample of 400 of the school's 5,500 students. All 400 respond and 100 admit to doing drugs. Carry out a significance test of the alpha equals 0.05 significance level. What conclusion should the counselor draw? So what's the difference in this problem?
This is two-sided.
So right here, she wants to know if it holds true, not if it's larger or if it's smaller. Okay, so that changes.
Miss Jones,
Yes,
on the last problem, did you mean to put positive 2.18 upper 10,000? Because I think that's why it was 98%. If you put it in the calculator like that.
I don't know. Oh, sorry. What are you saying I did?
You put negative 2.18 and then positive 10,000, and it gave you the like almost 100% chance because of that.
Right.
Were you supposed to put negative 2.18 or positive 2.18?
If you put in, let me show you. Oh, come on, calculator. Oh, sorry, it should be 2.18. 2.18. You see what it gives you? We can't.
Yeah.
Yeah, you can't do it that way. It's gotta be the
Oh.
negative because that's what your value is.
With TCDF, it's different.
Right, well, we're not doing, T is for mean, so we're doing proportions.
I was confusing them. Thank
It's
you.
okay, no worries. I'm glad you asked because I probably did do something wrong. The way today's going, it's likely. So if you have a question, please ask. No worries at all. All right. So on this last one, it becomes a two-sided. So the only thing that really changes is the hypothesis, the alternate hypothesis. Alpha was still the same. Your P is still the same. We're not changing that. So your state. Your plan is going to be the same thing. There is nothing any different in that whatsoever. Your do is where it will change. And not necessarily anything crazy. Z is still going to be 2.18. That doesn't change. But we can choose a probability. We can either do less than negative 2.18 or we can do greater than positive 2.18. It does not matter which one you do, they'll come out the same way, okay? So a second ago, we were doing greater than, so this is gonna flip. So I'm gonna do this one. This is the one that I'm gonna put in my calculator. Both of them will do the same thing. So normal CDF. I want less than negative 218, so what'll be my lower? My upper will be negative 2.18, 0, and 1, which will give you a p-value of 0.015. But what must I do to that p-value? Good. This is a one-sided p-value. So we need to make it two-sided. And because of rounding, it's going to be 0.029. If you put 0.03, it's fine. It doesn't matter. Okay, 0.03 is going to give you the same thing. This is a two-sided. So don't forget that. That's usually where people mess this one up. So how does that change our conclude? We're going to test our p-value against our alpha. If you got 0.03, that's fine as well. This is a rounded number, so this is also a rounded number. It doesn't matter, they're both going to be the same thing. So we can see that alpha is greater this time. So that means we do what? Reject H sub O. So we have convincing evidence in context that it does differ from the true mean. I mean, true proportion. There is a back to this. I didn't feel like I've been talking for 30 minutes. That's crazy. All right. Here's the back part. You will need to know these. What are the three ways to increase the power of a significance test to detect when H sub O is false and H sub A is true? You can increase your alpha. You can increase your sample size. And then you can increase your difference between the null and the parameter.
What is the power again?
Give me just a minute. How strong your test is. That's it. It's just how strong it is. So is it gonna make it significant? Is basically what it is.
Okay, thank you.
All right, so that's your 9.2. Just some highlights from 9.2 that you need to remember. Okay. And then 9.3 deals with means. So what are the 3 conditions that you check for means? So we know that the first 2 were random and 10% like always. What is the third one? Mhm. And the reason that we put normal on there is to remind you that if it is not greater than or equal to 30, what do you have to do? Make sure that you sketch that graph, make sure you label that graph. Again, that's why I do box plots, is because you guys can do that on your calculator and you can just trace it out. Okay, so what are your values? And then you don't have to worry about it. So number 2 says, what do you do if a large sample fails? We do graph. What are we looking for in the graph? No strong skew. No outliers. To assume normality. Make sure that you put that it's normal. Assume normal or assume normality after you graph it. I think there may be a part of your test. I know one version that I gave asked about the standard error, and we learned standard error probably a couple months ago. But SE is standard error. And it's just the standard deviation. So for means, it's going to be sample standard deviation over the square root of n, unless you have the population standard deviation, and then it's population standard deviation over the square root of n. How do you find degrees of freedom? N minus 1. On this one, how do you find the test statistic? It is a t. So what's your formula on this one?
Sample mean minus the mean that it gave you.
Over your standard deviation that we just wrote down. So what do you use to find the p-value? So on this one, remember, it's the probability of t. Our other one was z compared to the test statistic. This one is t compared to test statistic. And then this will tell you what your upper and lower and your degrees of freedom are coming from your n. So lower, upper, and degrees of freedom. So why didn't I write that about normal CDF? We've been using normal CDF since first semester. Okay, so you should know how to work that one. The only difference in this one is degrees of freedom. What extra step do you take if you have a 2-sided test and finding your p-value? Very good. And then we have 2 problems and we'll be done. Your first problem, it says a college profession, I'm sure it's supposed to say professor, suspects that students at his school are getting less than 8 hours of sleep at night on average. To test his belief, the professor asked a random sample of 15 students. How much sleep did you get last night? Here are the data. Again, he suspects that they're getting less than 8 hours of sleep. Do these data provide convincing evidence that the alpha equals 0.05 significance level in support of the professor's suspicion? Okay. So this is a state plan to conclude. Same concept. What do we need in the state? So our hypothesis this time is going to be mu. And he thinks that most people should get 8, but we're saying that they get less than 8. What does mu stand for? Hours of sleep. And then our alpha is 0.05. What are we going to do on this one? Before that, what kind of test? Sorry, you're going to check conditions or put it on there. It doesn't matter. A one sample what? And that's if conditions are met. And then we're going to check those conditions. I do not care what order you put that in. If you do your conditions first and then you say what you're doing, that's perfectly fine. Large sample. Normal. All right, so is it random? Yes or no?
Yes.
Yes. So random sample of 15. 10% would be 10 times 15 or 150. And we know that the population is greater than 150. And then large sample or normal condition, how do we check that? We have 15 as our sample size, which is less than 30. So what do we have to do? Okay, we're gonna have to put this in anyway. Remember where you put it into stat. I'm gonna hold my calculator. 3, 8, 9, 10, 4, 5, 3, 6, 7, 8, 8, 10, 5, 6, 6. And let me check it just a second before I screw anything up. 3, 8, 9, 10, 4, 5, 3, 6, 7, 8, 8, 10, 5, 6, 6. Okay. So I have the data in stat plot. We're going to turn it on, modified, we're good. Make sure there's nothing in y equals. And then zoom on. So here's my box plot. It looks pretty good. So again, you're going to make sure that you draw this box plot out. It doesn't have to be anything special. Try to make it look exactly the same. I'm going to trace it. And I get 3, 5, 6, 8, 10. Okay. So no strong skew. Biggest thing we're looking for is no outliers. So assume normality. On the do part, we're going to find our test statistic or our t value. Remember, I have my data in so I can find x bar and s sub x. How do I do that?
Stat calc 1 bars.
Perfect. Stat calc 1 bar stat. And we get x bar equals 6.53. If you want to go a couple more decimal places, that's fine. It doesn't matter. Mu sub O is in the problem. It is 8. S sub X, it is S sub X on your calculator, 2.29. and then n equals 15. So I'm going to define all those a second time. So 6.53 minus 8 over 2.29 over the square root of 15 gives us a p-value, or a t-value of 2.49, negative 2.49. So from our alternate, we know that t, we want to compare it less than 2.49, negative 2.49. So we're going to do TCDF. We need lower, upper, and degrees of freedom. Remember, degrees of freedom is n minus 1 or 14. So what is your lower if we want less than negative 2.49? What's your upper? And your degrees of freedom are 14, which gives us a p-value, and we want a one-sided p-value, so 0.013. So we're going to conclude by comparing our p-value to our alpha, our p-value of 0.013 to our alpha of 0.05. And we get our p-value as less than alpha, so we reject H sub O. We have convincing evidence in context of the problem that they do get less than 8 hours of sleep a night. Right. So the only thing, we're going to do one more problem, but the only thing that we haven't done is they spoke really quickly about differences at the end of 9.3, but it's still going to be a one sample. They just have the differences on there. So all you're working with are the differences. Okay. So you're going to get some on your test that say, find the difference or whatever, the mean difference, and compare that. So on that, there's going to be a lot of numbers in the chart, but the only thing you have to worry about is the difference, and it's going to be one sample. So we haven't even delved into two samples yet. So we will, just not yet. So at the cabbage factory, managers are interested in the size of cabbages this year compared to last year after using a new fertilizer to help growth. Last year, the mean weight of cabbages was 2 pounds. Managers feel like the cabbages have gotten larger. They take a sample of 34 cabbages and find that the sample mean is 1.9 with a standard deviation of 0.25. Based on the significance level, alpha equals 0.05. Does the data give convincing evidence that the manager's suspicions are accurate? So what do we do? Sorry. What do we do? What goes in our state? What goes in our state? And H of A for our hypotheses. What is our H sub O? Mu is equal to 2 because they were 2. What about H sub A? Yeah, because they say they've gotten larger. Not that there's a difference, but they've gotten larger. So that made it a one-sided. What else do I need in here? And it said the 0.05 level right here. And then the last thing, we're going to define whatever mu is. Okay, so make sure you define that. All right, so what is your plan? You're going to check conditions and your test. So is it random? It doesn't have the words random in there, but did they take a sample? It was a simple random sample. So anytime they say they take a sample, you're gonna assume that it's a random sample. So a sample of 34 is good. 10%, we're gonna do 10 times 34, which is 340. Pretty sure there's more than 340 cabbages in the factory. Okay, coming into that cabbage factory. So then large sample, 34 just barely makes it greater than or equal to 30, so I do not have to graph. And this is going to be a what? One sample t-test. Good. One sample t-test. So write your formula out. X bar minus mu sub O over S sub X over the square root of N. You can define them or not. It does not matter. They've already told you what is your mean. Sample mean was 1.9. Your mu sub O was 2. Here's your sample mean. Standard deviation was over square root of 34. Again, having the formula and then having this defines those variables. Okay, so you don't have to redo it again on the side like I've been doing. This gives you a negative 2.33. So we're doing the probability that T is what? Greater than, because that's what our alternative said. To negative 2.33. So we do TCDF. We do lower. What's our lower going to be? What's our upper going to be? And then our degrees of freedom are 33. This gives you a one-sided p-value of 0.9869. So we're going to conclude by comparing our p-value to our alpha, so 0.9869, 0.05. We know that our p-value is greater. So we fail to reject H sub O. We do not have convincing evidence in context of the problem that the cabbages are greater than 2. That the mean weight of cabbages after using the new fertilizer is greater than 2. Any questions? Everybody good? All right. So that is it. Use these again, the 9.1 you should have, and if you don't have, go back and look where we did that section 9.1 in your notes videos. They should be in there. Okay. If you don't have it, grab it from somebody. You guys can take pictures of it. That's fine. Make sure that you upload all 3 of them, please. Make sure you upload all 3 of them for today. All right. I'm going to stop sharing and stop recording.